All right, in this video, we are going to talk about relationships in a UML diagram. Many times, objects and methods from one class use objects and methods of other classes. We've seen that a lot during the past semester and a half. And so what we want to be able to do is to reflect those relationships in UML class diagrams. So in our project, we'll have a lot of rectangles that represent classes, and then we are going to use arrows of various types to illustrate relationships between classes. Okay, so we are going to look at two different types of relationships. First, use relationships, and then secondly, inheritance relationships. All right, so first off, we'll talk about use relationships. One word of warning here. When you look at different references and different websites and books related to these concepts that we're about to talk about, you'll find slightly different versions from different sources, and so it doesn't seem to be universal and everything's set, and so you'll see people a lot of times have differing opinions about some of these concepts here. And that's fine. Remember, this stuff is meant to be a design tool. And so it's not, it doesn't have to be exactly the same for everybody. Some people have different opinions about this, and that's okay. So, just keep that in mind. Just like when we're talking about model view controller, issues and things like that, there doesn't seem to be one common thing that everybody agrees on related to that. It's everybody's opinions is kind of generally the same, but there's differences in there, and sometimes people seem to make a big deal about those differences. So just keep that in mind. All right, so the way we're going to do it is talk about these four relationships: dependency, association, aggregation, and composition. And those relationships are listed in order from the weakest, dependency, to composition, which is the strongest one. Okay. All right. So let's start with dependency. So a dependency, all right, we would say a class depends on another class if it manipulates objects of the other class in any way. All right. So you can think of that kind of relationship between classes as uses temporarily relationship. That's kind of the best description that I've found of that. All right, so uses temporarily. So here I have a class A, right, and a class B. So we would say, hey, this class A uses temporarily class B. And I'll give some real world examples of that and some code examples of that as we go through. So how do we illustrate that in a UML diagram? We illustrate a dependency with a dashed arrow like this and an open arrowhead here. So you can see here the class A temporarily uses the class B. All right, and so that's kind of the UML depiction of this relationship. So as an example, let's say we have an object of one class A and it uses another object of class B. This is the way that it would be illustrated in a UML diagram. All right, and an example of how you would see a dependency in code is we have, say, this class called Calendar Manager, and inside the Calendar Manager class, there's a method called setDate, and you can see that the parameter to this setDate method is a datetime object. Okay, and so this datetime object gets passed into this Calendar Manager class, but you can see that it's not really saved. Once this method is over with, then boom, that reference to datetime will be gone, right, or at least not used anymore. And so eventually it will be cleaned up. So it's going to go away. So it's not like the date time is really a part of the calendar manager class. The calendar manager class is just using the date time object. So it's a parameter. So in UML, this would be depicted like this. Here we have the calendar manager class. It temporarily uses the date time class. So we have this dashed arrow with an open arrowhead pointing to the date time class. Okay. So in Visio, what you would do to implement that is if you drag two classes out here and here, and then if you go here to the connector, you can connect those two classes up. Oops, you have to click on it and then drag it over here like so. And then oops, I didn't want to do that, so undo. And then go back to the pointer tool. If I move this class around, you can see it kind of updates where that class is. If you want it perfectly lined up, you can see how there's this little where it bends a little in there. If you want to get rid of that, just hold down the shift key and then move this around. Actually, it's not shift, that's D I'm thinking of. Oh, there we go. No. All right, I had it there for a second. There we go. Okay, and you can see this doesn't illustrate the dependency, so what you want to do, because it's not dashed, we need it dashed first off, and then with an arrowhead on there. So what you would do is, once you get it the way you want to, right-click it, and then go to Set Connector Type, and then you click on Dependency, and you can see it draws the dependency in there for you, like that. Okay? All right. So that's what an example would look like in code, and then I like to try to give a real-world example. So a person uses a fork, right? A fork is not a part of a person, right? It's just something that the person uses, right, temporarily, and that's it. So that's kind of how I like to think of dependency. All right. Next up is association. So association can be thought of as uses or has a relationship. All right. So to represent that, what we would in a UML diagram, right, for the bidirectional association where they use each other or they both have an instance of each other, it's represented by a solid line with no arrowheads. All right. And for a unidirectional association, there would be an open arrowhead pointing in one direction or the other. So as an example of that, let's say an object A uses an object of another class B and stores that object as a field. So one of the fields of A, the class A, is of type B. And then an object of class B also stores an object of class A in its field, right? So you would indicate that by a solid line like this, a bidirectional, with no arrowheads for the bidirectional. So just as an example, let's say you're writing some software, right, to manage classes and courses and students at a school. Then you might have a class for a course, right? And inside that course, you might have a list of students, right? The list of students who are enrolled in the course. And likewise for each student, right? Each student takes courses, and so you would have a list of courses in the student class, right? You would have a list of courses or array, right, of courses that the student is taking, okay, or has taken. And so in the UML diagram, that would be represented like this, with a class for course and a class for student. Right, and then it's a bidirectional relationship. So because course has students involved in the fields, and student has course field that involves courses, right, then that's a bidirectional relationship like that. So if I go back to Visio and try to do that, right click, set connector type, and that would be an association like so. And then I'm not sure about let's see. For a unidirectional one, I think it's directed association. There we go. So that's what a unidirectional relationship would look like. So in Visio, they call it directed association. Okay. All right. And of course, this is a real world example, right? This course has students, right? A course object would need to know about students in the course. Students have courses. A student object would need to know about the courses for which a student is registered, right? So that's what we would look like. And I already showed you what the unidirectional association would look like for that. All right, now you may say, hey, well, wait a second. If I've got a class A, right, and it has a field of class B, shouldn't that go in the class diagram, And same thing, right, here. So here this shows a unidirectional association. So most likely, right, in code that's implemented in by A having B as a field inside there. So wouldn't it make sense to do it like this? Here you can see B is listed as a field or attribute, right, inside that class, a private field named lowercase b of type capital B in here. So which way do I need to do it? Should I do it this way? Should I do it this way? Okay. Well, the main thing is in the guidelines you should go by are these, right? If the class is very, very simple, right, like extremely simple class, then you probably want to go this way and list it as an attribute. Otherwise, right, if B is more complicated, then you probably want to do it this way, like so, okay? The main thing is don't do both, all right? It's fine to do it either way. Don't combine these. So either do it like this or like this if you're going to use the attribute way, all right? So those are the guidelines for that. All right, the next relationship that we'll talk about is aggregation. So aggregation can be thought of as is part of relationship, okay? And aggregation is shown by a solid line with an unfilled diamond arrowhead like this, okay? So in Visio, it would look like, so set connector type aggregation like this, okay? And you can see it goes on the opposite end over here. This class aggregates this class. All right, an object of one class A is made up of a B object, right? Here, B is an integral part of A, okay? So, as an example that you might have, here I have a mailbox class, so maybe you're writing some software that runs voice over IP phone, right? And it has a greeting. So that greeting, right, you would have a mailbox, right, for voicemail. And as part of that voicemail, you would have some greeting, letting callers know to leave a message if they don't reach the person that they're trying to reach. So that would be an integral part of the greeting would be an integral part of the mailbox here. So you can see the diamond, unfilled diamond goes over here. Another good example is an engine, right, is a part of a car. An engine is an integral part, right, of a car. If you don't have an engine, is it even really a car? Okay. No, it's probably just sitting there not doing anything, right? So you can see that's a stronger relationship than the association there potentially. They are very similar concepts, right? Association and aggregation. And so how do you know which one to use, right? So the guidelines here are use aggregation or composition, which we haven't quite talked about yet, only if a class actively manages objects of another class, okay? So for instance, for the course and the student, you might say, yeah, they are definitely parts of each other, right? But does one actively manage objects of the other class? Whereas a car, right, if you had an engine in it, it's going to do that as manage the engine, right? It's definitely going to have stronger connection with the engine, right? And so I've also seen some people that just kind of use one. They kind of just roll this into one as well. So some people either seem to use association or aggregation and don't make a distinction. They just pick one and go with it. So I've also seen that happen as well. All right, composition. And composition can be thought of as is part of and has a lifetime dependency on a relationship. All right. And so that would be an example where, say, like here we have an object A, it's made up of an object B, right? It's an integral part of it. And it's also responsible for the creation and existence of that object B. So it's an even stronger form of the aggregation relationship. Now you can see it's indicated by a filled diamond here. So if I change this one to a filled diamond, you can see it fills in the diamond here on the UML chart. So as a real world example, you can say a house, right? It consists of room objects, right? You can think of a house that way, right? But the room object doesn't really exist outside of the house, right? In the creation of the house, the rooms are created, right? When you build a house, it creates the rooms. So the room wouldn't even be in existence if it wasn't for the house, right? And then likewise, if you think about, hey, if I destroy the house, right, would it destroy? It would destroy any of those rooms, right? In the house. So in other words, the room is not going to be existing outside of the house. You can see that's a stronger form. A room is part of a house, right? But it begins and ends with the house itself. Whereas with aggregation, you don't really have that, right? In other words, if you go back to the car and engine example that we used, right, you can build an engine separate from the body and frame of a car, right, and then put the engine inside of the car. Yeah, the engine is an integral part, right, of the car, but it doesn't really, the body and frame of the car doesn't really form the engine. It's a part of it, sure, but like here, room and house, right, you're not going to have these rooms without the house. If the house were to go away, that's also means all of the rooms are going to go away as well. All right. Let's see if I have it in code. No, I don't have that. But in the code, basically, what you would have is where this object is instantiated inside of the class. Is one way to think about it in code for the composition example. Okay, so that is it on the use relationships. I'm going to separate out the multiplicities and the inheritance relationships in subsequent videos.